let's say that we have a linked list. We've got some numbers in it. We want to find a particular position of some info. So our linked list is going to start with our start head. And this is going to be connected to a node with some data, let's say maybe 1, and then another node with data 2, and another node with data 3, and then finally pointing to our last node, which is null. Let's say that we want to find this element 2. How could we do this? Well, we covered inserting things into a list, deleting things from a list, and looping through a list. So what we want to do is loop through the list, and we want to stop once we're sure that the info is equal to 2. So to really understand how to do this, we've got to talk about a thing called control. So in C, we can see that if the info in the node is equal to 2, is equal to 2, let's put the number 2, then we want to break. Sorry, my writing's kind of bad. Then we want to break. So how do you implement this in code? Well, we use the keyword if. We can use the keyword if. If will take in what's known as a conditional statement, so conditional. And if that statement is true, it'll execute code within the curly braces. And if it's false, we can use another keyword called else. And once we get to else, we can execute if this is false. Okay. So what does a conditional mean? So we have these things called booleans in code. And what we're going to equate that to is 0 is false and 1 is true. Now, if you look up Boolean variables and Boolean rules, I'm not going to go through all that stuff. I just want to be able to go over the case where if it's 0, it's false, and if it's 1, it's true. So in code, what we would represent this statement written above as is if our variable that we're going to pass in, let's say if an unknown, if the info is equal to 2, then we're going to execute this code in here. We're going to use the double equal sign as a Boolean operator. If the info is equal to 2, then we're going to print OK and break. Else print not OK and yeah, we're gonna print not OK, and then what's gonna happen is as we're traversing through the list, this is going on, and as we traverse through the list, it's gonna hit the end, and then it's gonna print not OK. Okay, so the other keyword that we can use in C, we learned about a for loop, which is going to execute for a duration of time until we meet some condition. Now the other thing that we got to cover is a while loop. A while loop is going to take a condition and it's going to execute the code within these curly braces until the condition is false or we break. So we're going to keep on going through until this thing in here is false or it hits the keyword break. So using these two new things in our toolbox, we can write a program that will not only build a list, which we saw in the last video, last section, but we can also search through the list and find the particular position of some info stored in a node. Alright, let's get some practice in here. We'll go all the way through it, building the list all over again to implementing our little function to search for a particular piece of data. Alright, so we made a linked list last time. Let's go all the way through and just do it all over again for good practice. So we're going to call this search linked list in our folder. And we're going to add a new file, search.c, another new file, search.h. Okay, so search.c. Well, let's include standard lib, our standard library, and input and output, something so we can print f and scan f things in. Alright, so we need to first insert something into an empty list. So we know that we're going to, well, before we make any functions at all, we got to have our data structure that we're going to use to store data in. So we're going to need to make a node type. So we need struct int info, struct node, pointer, link. And now we'll make a couple functions. So the first one that we're going to need is inserting something into an empty list. So it's going to return a type struct node pointer. It's going to take in our head pointing node, our start nodes, struct node pointer start, info, the data that we're storing in that first node. Oh, and we've got a semicolon up here. And struct node insert, we'll call it insert at end. So this is the one where we loop all the way through the list, and then once we get the end, we know that we're at the end of the list, we will just go ahead and modify the end of the list and add another node to it. These look really similar, and the only difference between these functions, I guess these really could be combined into just one function where there's just something that checks a condition. Maybe at the end of the video I'll show you guys how we can modify that, but one has a loop, one doesn't. And then we need something that will create our list. Struct node create list, struct node start, and let's go ahead and we need our void show list. It's going to show us everything in the list. That's got to take in our main head pointer here, start, and let's make it void search list. So what this will do is it'll search through the list. If it finds it, it'll print out we found the element, and it'll print out the position that it was found. Otherwise, it'll say it wasn't found in the list. So struct node start, and the thing that we're looking for, we're always trying to find x, right? So let's call it x. And now let's actually make a program. Oh yeah, I like doing this. I like doing this before I start writing a bunch of code. I grab all the definitions from the top, I put them down here, and and then if you hit Control Alt, you can multiple cursor select. I just hit the down arrow key as I do that. Backspace. Let's drop some curly braces in there, and then another line spacing for formatting. So what are we going to need? First, we need to create our start pointer, so struct node start, and we have to give start some memory, so struct node malloc memory allocate size of struct node, and set it equal to null. Okay, so the first thing that we want to do is create our list. So start equals create list, pass in start. So what's going to happen is we're going to hit this line of code, and start's going to be passed into create list. We're going to go through the process of creating a list and then reassign start. And let's show the list after. Let's show the list after we've done this, just to make sure that everything's been done correctly. Oh, yeah, show list has to take in start. Okay. And here we'll use a while loop. So while this, we'll just have something that runs until we break it. So while this is 1, so it's going to run forever. So this is really important. This loop will never stop unless we actually use the keyword break somewhere in here. We have to use the keyword break for this loop to actually stop at some point. So let's give the user 2 options. So printf, we'll give them the first option will be enter 0 to search for an element in the list. And let's break it with a new line character. And then if you hit Shift Alt and down arrow, we can copy this line down here again and enter 1 to quit the program. So we have 2 cases. The user could enter a 0 or the user could enter a 1. And we'll get that input here. And we need to pass in a reference, and we'll call this choice. So that means that we need to add another variable here. Let's put that in above this struct stuff. We'll call it int choice. Okay. So we're going to get the user input on this line, on line 28, and it's either going to be a 0 or 1. I'm not going to worry about guarding this. This is just like a fun little program to put together to learn data structures. So if it's a 1, so if choice, remember how we looked at conditionals, if it's a 1, it's going to be true. So if it's 1, then we're going to break the loop. And if it's not, we're going to run search list, pass in start, and a reference to the element that the user wants to search for. So we'll need another integer type up here, so we'll call it x. We got to get what the user wants to search for. So printf, please enter the number that you would like to search for. Okay, and we'll scan that. I say scan it, we'll just get it as input. And we do not need to pass in a reference to x here, we just need to pass in x. Alright, so that's our whole program. If everything works, if everything's set up properly, this program's gonna first set these variables up here. So we're gonna get our integer choice and x. Then we're gonna create a start node. We're gonna pass that in. We're gonna reassign start to our created list. We're gonna show what the list is gonna look like. So we're gonna see our list after that. It's gonna go into this while loop, and then we're gonna print out 2 statements and accept a user input. Once the user enters their input, if it's a 1, we're going to quit the program. If it's a 0, they're going to search for something in the list. So now we just need to go over the code for inserting elements in a list to build a list. So why don't we go over create list first. So create list, we saw this in the last video, so we're going to have int, info, and n, where info is going to be the data that we're going to insert into our list, and n is the size of the list that we want to generate. So let's get the size of the list from the user. Please enter the size of the list. Alright, let's get that from the user. And then the first case we want to do is we want to insert it into an empty list. So printf, please enter the data that you would like to store in node 1, right? The first element. So we'll get that from the user, scanf, and we're using integer formatting and info. Start. So we're going to pass, we're taking in start in here into our function. We're taking start as an argument. Now we're going to reassign start by passing it into insert in empty. Pass in our data. Once that's done, we've inserted something into our list, so start's no longer pointing to null. It's actually going to be pointing to the temp node that we just inserted. So then we'll loop through however many more nodes that the user wants to add. For int I equal to 1, I less than n, I plus plus. Let's just copy this line from, police, okay. Let's copy this line from here. So I'm going to hit shift and I'm going to press the home, not numlock, I'm going to press shift and then the home key to highlight this line, control C, and then control shift K to delete that line, enter, control V to paste that line. And we're not going to keep on printing out, please enter the data you'd like to store in node 1. We want to say, please enter the data that you would like to store in node, not I, because if we did I, we would be one node behind the actual node we want to print out, because we're starting with 1. So we're going to print I plus 1. That way, the first time this program runs, we're going to get, please enter the data you'd like to store in node 1. They're going to enter it, and then the next thing is going to be, please enter the data that you would like to store at node I plus 1, which is going to be 2 on the first iteration. So it's going to go enter the data you like to store in node 1, in node 2, in node 3, in node 4, in node 5, etc. Okay. Scanf, %d, pass in info. This is going to reassign the info, so we're going to get the info that the user wants to insert in the list. And then we need to reassign start. Insert at end. So once we run insert at end, it's going to take our start and add a bunch of nodes to it, and then we're going to reassign that to start every single time. And then once we're done with create list, we want to return start, the beginning of our list, a pointer. Okay, so we are using this function insert and empty and this function insert end, but we haven't actually made those. So let's go ahead and do insert and empty first. We saw this in the previous video, so we're going to create our temporary node. This is the little box that's going to be sitting outside of our list at first. And that little box is going to need some memory. So struct node star malloc size of struct node temp info equals info. So we're just assigning the info that the user wants to enter to this temporary node. So since this is an empty list, start's going to be pointing to null. We want the end of our list pointing to null. So why don't we take the link from temp and point that to start, since, temp link. Ooh, I got confused there. Temp link pointing to start. What this is going to do is it's going to set temp, it's going to set temp pointing to null, because start on the first pass should be null. This is not like the best, most flexible program, but again, it's just a demonstration to see how to build a list and work with some simple tools and see. And then we're going to return start. So what this is going to do is just going to put one node into our list, and then start is going to be pointing to temp, and temp is going to be pointing to null, and we have our first node inserted in our list. Now we're going to actually repeat the same code. Watch this. We can use all the same stuff in this function. You can use all the same stuff in this function, except the only thing we're going to need is a pointer to skip through the list, so we'll need p, and then we're going to set p equal to start, and then while p link is not equal to null, so the node just before the end of the list, so we're going to be in the very last node, well, p link is not equal to null, we're going to run the rest of this code. We're going to skip to the end of the list. I realize this is a capital P. Gotta make that into lowercase. That's why I was throwing that error. And this is a capital P. So we're going to skip to the list. To do that, we have to keep on reassigning P. As we skip through the list, we're going to finally get to that last node where the P link is going to be pointing to null. And at that point, right at the end of the list, we're going to just change temp link to be pointing to, it's going to be a little bit different. It's not going to be pointing to start, so you can't actually use this code. It's very similar though. So temp link's not going to be pointing to start. We're going to have to take that last node pointer, p link. See how this is like a node that we're trying to extend what this node is pointing to for temp link. And here p link's going to be the last node that we're going to be at. So we want p link to point to start. Sorry, not p link pointing to start. We want p link pointing to temp. So what does that mean? It means p link's no longer be pointing to null, because this thing breaks once p link is pointing to null. So now p link's going to be pointing to temp, which is our temporary node that we're trying to add to the end. And if temp is the node that we just added to the end, well, we don't want to do this. What should temp point to? If it's at the end of the list, what does our linked list end with? What should it be pointing to? No. So yeah, this could be, my challenge is take these two functions and then using the stuff that we learned from an if statement, try and see if you can handle the case if start is equal to null, what should happen? And if start is not equal to null, what should happen? That's a very good hint to how to proceed in this and how to make this into one function. But we haven't even tested this, so we'll have to see if this even works. Alright, so showing the list is pretty easy. This is kind of a fun one. We just have to create our skipping pointer. Maybe that's what I'll call that from now on. Our skipping pointer, P. And P is going to be, we have to start as start obviously, and then while Well, our pointer is not equal to null. We're just going to bounce through the list and print out the data. Printf integer formatting %d p info. And we have to keep on bouncing, right? So we got to keep on reassigning p link. And let's print a new line character at the end to break all this stuff off. I want to make sure we're using new line characters for all of our print statements. Otherwise, everything's going to get shoved into one line. Yep. Okay. It's all using new line characters. All right. So finally, we're at search. Search is going to be really similar to show list. So let's go ahead and just copy this code. So we're going to take that skipping pointer and we're going to skip through the list. But we don't want to go all the way to the end of the list because if p is pointing to null, there's not going to be any info available anyway. So it's going to be p link, just like we did for insert at end. And we're not going to print out all the data every single time. We want to print out the data. We want to do something if the info is equal to x. So if p info equals x, printf. We're going to say x was found at node, whatever the node was. So x, and we're going to have to somehow keep track of the position of the nodes. So let's use a counter. So make a integer up here, int count. And we'll set it equal to 0, just initialize it at 0. And then the first pass, we want this to print out x was found at node 1, or x was found at node 2, or x was found at node 3. So how to keep track of the count? Well, rather than rewriting count equals 1, count equals 2, count equals 3, count equals 4, count equals 5, there's a shorthand way that we can do it. And if you're familiar with other programming languages, it doesn't have to be plus equals 1 or anything like that. We can just use plus plus. This is called the postfix operator, and what it does is it will increment count. So on the first pass, count is going to be 1. It's going to be 1 before it hits here. So it's going to go from 0 to 1, come here. Second time around, it's going to become 1 to 2, print out 2, 2 to 3, print out 3. And so each time we're going to get the correct node. Alright, so I think this is going to be, yeah, that looks pretty good. Alright, now we probably have a bunch of errors because this is the first time that we've actually looked at this. So let's go ahead and put this in the terminal. So let's go ahead and click down in the terminal. So I'm going to drop down into the terminal here. And we're in linked. Okay, hang on. The terminal's not opening. Alright, so we're going to drop down in the terminal here. And now we're going to cd into search linked list, and we're going to compile search, so search.c -o, we'll call it prog. Let's go ahead and run that. So the size of the list, 5, 1, 2, 3, whoop. Something's happening here. So it looks like our program crashed at 3. This could be kind of interesting here. Let's see what's going on. So it looks like it's crashing right about here. So maybe it's something wrong with insert at end. Let's look at insert at end. So we're creating our temporary node, our skipping node P, assigning memory. That looks good. That looks good. P link equals temp. Oh, and we don't want to make temp null after that. We want temp link to point to null. That's the thing. Okay, so let's drop back down to the terminal and recompile. Alright, so 5. We'll do a list of size 5, and we'll just keep it really simple. 1 into 1, 2 into 2, 3 into 3, 4 into 4, 5 into 5. Hey, look at that. Our list looks great. 1, 2, 3, 4, 5. And let's press 0 to search for an element into the list, and we're going to search for 4, and it should say that it was found at node 4. 4 was found at node 4. Let's try again. 1. 1 was found at node 1. And let's press 1 to quit the program, and it quits the program. Cool. Well, if you enjoyed this video on C, I'm making lots of videos on C, and we're always going to go through a step-by-step process of building out a program from scratch. So if you like this video, like and subscribe, you'll definitely get more content. Thank you for watching.